Welcome back to Tracing the Sky. So in the last video, I left you a little bit of homework. I wanted you to go out on a sunny day, put a stick in the ground, notice the shadow made by where the sun is and the stick, and keep track of that shadow as the sun was moving through the sky and see what you observed. So today we're going to do a version of that experiment together. Well, unfortunately where I live in Canada, it's been pretty cloudy. We're in the fall months, so the weather hasn't been great. And so I haven't found a good time to film this outside, but that's okay. I've got this light up here that will be our sun, and I've got this cactus, and we'll see what kind of shadow that our lamp casts with this cactus and what happens to that shadow as we move the light. So let's have a look. Okay, so here I am on the floor of my office and I've got my light and my cactus. And what I'll do is I'll just show you what happens as we move the light. So right now you can see that the light is directly overhead the cactus. And you can see that there's a shadow here from the arms of the cactus. So the light is directly overhead. Now, imagine that's the sun directly overhead, right? Directly overhead your stick. You can imagine that you would have very little to no shadow, right? If you've just got a straight stick, right, with no arms like my cactus has, then there's probably no shadow. But you can see I've got a little shadow cast by the arms down. Now, what happens if I move my light source so that it's kind of like lower on the horizon or closer to my floor? So I'm kind of moving it at an angle now, so it's not directly overhead the cactus, and it's hitting it from an angle, and you can see that the shadow got longer. So you can see that the shadow's getting longer, and let's continue to do that. I'll move it lower and lower and lower and more at a side angle, and you can see that the shadow is getting longer and longer. Now let me go the other direction. So if I move the lamp a little higher overhead in the cactus, you can see it's getting shorter. So let me just show you that. So I'm going from a side angle, I'm making the light go lower towards the floor, and you can see the shadow's longer. And as I move the light higher above, the shadow gets smaller and shorter. So that's super interesting. Now imagine this is the sun, right? This is the your stick in the ground, and this is the sun. As the sun is closer to the horizon, your shadow of your stick was probably longer, right? And as the sun rose in the sky, just like this, your shadow was shorter. Okay, so here we are from a little bit of a different perspective. We're going to look at things from the perspective of the lamp. And I want to do this so you can kind of get an idea of what's happening from the sun's perspective too. So you can see we've got a shadow being cast, and it's pointing kind of in the same direction that the lamp is pointing in, right? And look at what happens when I move the lamp overhead. You can see that the shadow is getting shorter as the lamp is further overhead. And if I make the lamp go more to the side or lower towards the ground, the shadow gets longer. Now look at what happens when I move the lamp in either direction. When I move the lamp to the right, you can see that the shadow is moving in the opposite direction. The shadow is moving to the left. And if I move the lamp to the left here, the shadow is moving to the right. So the shadow moves in the opposite direction that the light source is. And you can imagine a similar thing is going on with the sun. As the sun is traveling around or along its arc, the shadow is going to move direction as the sun moves across the sky. Okay, so if you did this experiment outside with a stick in the ground in the sun, you probably saw something very similar. As the sun was rising in the early morning, your shadows would have been longest. The sun would have been lower in the sky and coming at your stick from the side, and so it would have cast a longer shadow. But as the sun rises in the sky, the shadow would get shorter. It would get to a short point as the sun kind of crests our arc, and then it would start to get longer again. And you would also notice that the direction that the shadow is pointing would be opposite of wherever the sun is in the sky. So if the sun's in the east, the shadow is going to be pointing west. And if the sun's in the west, the shadow is going to be pointing east. Okay, so I want to point out one important thing. We've got our sun traveling in an arc from east to west, right? And there's going to be one point in which the sun is highest. If you draw a line just touching the top of our arc, you can see that it touches the arc in just one place. And that's going to be the point in which the sun is highest. And what that means is every day there's only one point where the sun's highest and the shadow is shortest. And that's really, really important. Okay, so why is this so important and how can it be useful to us? Well, remember, our goal is to see how the sun's moving over the course of time. We want to compare how it's moving day after day after day. So to make that easier for us, here's what we can do. Instead of tracking the sun over the course of an entire day, every single day, we can wait until the sun's pretty high in the sky, right? While it's still rising, but pretty high, right? Not when it's first rising low in the sky, but when we see it starting to get pretty high. And what we can do during that time is place a stone wherever the shadow ends, right? So we've got our stick in the ground and we've got the sun pretty high in the sky. And we're going to place a stone every time we notice the shadow moves. So it's going to be a period where we have to be super focused. And what we would notice is that the shadow would get shorter. And so our stones would get closer to the stick. And they're going to keep getting closer until a certain point, until the point that the sun is highest. And then the stones are going to get further away as the shadow gets further away. And as soon as that happens, we want to stop. So we can stop as soon as the stones start to get further away, because that means the sun is starting to get lower in the sky. And all we care about is the point at which the sun is highest and the shadow is shortest. And so what we could do is take away all the other stones and just leave the mark and the point in which the sun was highest and the shadow was shortest. And so every day, all you would have to do is repeat this. Measure the point in which the shadow is shortest and keep a marker so that you can compare each day. Is the shadow getting shorter over time or longer? Now, what do you think would happen? Over the course of time, based off what we looked at with the seasons and the length of the day changing, what do you think would happen to the shadow over time? Would the shadow be shortest at its shortest point in the summer months or the winter months? So in the summer month, the days are longer. The sun's spending more time in the sky each day. And I bet you can imagine how that would relate to our shadow. If you were to do our experiment day after day, especially in the summer months, you would see that the shadows are getting shorter as we approach summer, and they're shortest in the summer months when the days are longer. And that makes sense, right? If the sun's path is higher in the sky, if the arc is wider, we're going to have longer days. And because the sun's path is higher, the shadows are also going to be shorter. Now, we also know that our seasons repeat, right? So we experience the days getting longer in the summer, and then they start to get shorter again and colder, and we go into the winter months, and then it goes back to being warmer again. And if you did our experiment day after day over time, you would see that our shadow length starts to cycle in a similar way. As we approach the summer months, the shortest shadow each day is getting shorter and shorter and shorter until a certain point. Then it's the shortest it's going to be for all of the seasons. And then it's going to start getting longer and longer and longer. And it's going to continue to repeat itself. Now, can you guess how many days are between when the shadow is shortest and when it comes back around to being shortest again? Right? If you put a stone in the ground every day, marking where the shadow is shortest, and you counted how many stones you have, one stone for every day, how many stones would you have between shortest shadows? Well, I bet you have a pretty good idea of what the answer is. If you were to count how many days were between the shortest shadow and the shortest shadow, you would have 365 days. And we all know what that is. That's the length of our calendar year, right? There are 365 days in a single year. And so that's what we can describe as the annual motion of the sun, right? It takes the sun 1 year to repeat its cycle. And a year is 365 days. And so what are we really talking about here then? Well, we're talking about the amount of time it takes for the sun to repeat the kind of path that it's taking, right? So every day it's traveling a slightly different path. As we're approaching the summer month, it's getting higher in the sky. And as we're approaching the winter months, it's traveling on a path that takes it lower in the sky. And it takes it a year to repeat every time. Okay, well, we've taken a really big step today. We now can describe the sun's motion in two ways. We know that there's a daily motion, how it moves on a single day from east to west in an arc. But now we have this idea of the annual motion of the sun, how the sun is moving over the course of an entire year and how it's repeating that motion year after year. So in the next video, we're going to tie this all together with the stars and see how ancient astronomers use this information in their day-to-day lives. And then we'll start to look ahead towards the moon and planets. I'll see you next time.